Voyager 1, launched on September 5th, 1977, is one of the most amazing machines ever sent from Earth into space. What makes it so special is that it is now the farthest human-made object from Earth. To give you an idea of how far it is, Voyager 1 is about 15.5 billion miles away from us right now. To put it into perspective, if you were to drive a car non-stop at 60 miles per hour, it would take you almost 30 million years to reach Voyager 1. Even if you flew in a jet traveling at about 500 miles per hour, it would still take you more than 3 million years. And yet, despite this huge distance, we can still send commands to Voyager 1, and it can send information back to us. So how is that possible? How can we communicate with something so far away in space? And how much longer will we be able to talk to Voyager 1 before it moves too far to reach? Before we answer those questions, let's talk about Voyager 2. Although Voyager 2 was actually launched first, on August 20th, 1977, both spacecraft look almost exactly the same, and were made for the same mission: to explore the outer planets in our solar system, the ones beyond Jupiter. Getting to those outer planets is not easy. So, scientists planned the launch carefully, taking advantage of a very special event. In 1977, Jupiter, Saturn, Uranus, and Neptune all lined up in the same general direction from Earth. This alignment is extremely rare. So rare that it won't happen again until the year 2150. Because the planets were lined up like that, the spacecraft could use their gravity to quote-unquote slingshot themselves from one planet to the next, gaining speed without needing more fuel. Voyager 1 used this trick to fly past Jupiter and Saturn, sending back incredible photos and information. One of the amazing things it showed us was detailed pictures of Jupiter's thick atmosphere. Before Voyager, scientists didn't even know Jupiter had faint rings. But Voyager 1 confirmed they were there. It also discovered volcanoes that were still erupting on Jupiter's moon. Meanwhile, Voyager 2 went on a different path to explore Uranus and Neptune. Voyager 2 took detailed photos and sent back lots of new information about these distant planets for the first time in history. After finishing their main missions, both Voyagers kept flying farther and farther away from Earth, heading toward the edge of our solar system. The two Voyager spacecraft have now left the heliosphere. But what does that mean? The heliosphere is like a huge bubble around the sun, created by something called the solar wind. The solar wind is made up of tiny charged particles that come out from the sun all the time. These particles zoom away from the sun in every direction and push against space around it. Voyager 1 and Voyager 2 were the first spacecraft to ever cross this boundary and leave the heliosphere. Scientists can tell this from the data Voyager sends back. Far beyond the heliosphere is the Oort cloud. The Oort cloud is a huge, mysterious shell of icy rocks and comets that surrounds the sun very far away. Scientists believe it exists, but it's too far for us to see clearly. Now, to put this in perspective, Voyager would need to travel another 300 years to even get to the Oort cloud, and around 30,000 years to pass all the way through it. That's about how long we humans have been on Earth. Each Voyager spacecraft has a dish antenna that's 12 feet across. The dish sends out radio signals, almost like tiny messages, but with only 22 watts of power. Now, because Voyager is so far away, it takes a long time for these signals to reach Earth, about 22.5 hours. To understand how far that is, light takes just over 1 second to get from Earth to the Moon, and about 20 minutes to travel to Mars. So Voyager is sending signals from a distance much greater than those. However, signals get weaker the farther they travel, following something called the inverse square law. This means that when Voyager's 22-watt signal reaches Earth, it has become incredibly faint. To catch such faint signals, NASA uses huge antennas that are 230 feet wide, about the size of a 20-story building laid horizontally. These huge antennas are part of a network called the Deep Space Network. The Deep Space Network has 3 main locations around the world. One in California, one in Madrid, Spain, and one in Canberra, Australia. Having antennas around the world means one of them can always, quote-unquote, see Voyager and keep communicating 24 hours a day. But running the spacecraft and its instruments also needs power. Voyager can't use solar panels like satellites close to Earth because the sun is too faint out there. Instead, Voyager uses a special nuclear power source called radioisotope thermoelectric generators, or RTGs. These devices turn the heat from the slow decay of plutonium, a radioactive material, into electricity, giving Voyager power for its instruments. When the Voyager spacecraft were first launched back in 1977, each Voyager made over 400 watts of electrical power. But now, after almost 50 years of traveling through space, this power has dropped to less than 200 watts. That's because the plutonium inside the RTGs slowly loses its strength over time. Because the Voyagers have less energy now, NASA has had to carefully shut down some parts of the spacecraft that aren't necessary anymore to conserve power. One of the most famous things Voyager 1 did was take a photo of Earth from almost 4 billion miles away. That's about 40 times the distance from the Earth to the Sun. From that distance, Earth looks so tiny that Voyager captured it as just one small dot of light. This picture is called the pale blue dot. It's special because it shows our whole world as seen from a point beyond all the planets, reminding us how small and fragile our home is in the vast universe. After taking this last photo, Voyager 1 turned off its camera forever to save precious power. Originally, Voyager 1 carried 10 different scientific instruments at the start of its mission, but now only a few are still working. These remaining instruments mainly focus on studying magnetic fields and charged particles in the space beyond our solar system's heliosphere. However, the power from the spacecraft's nuclear battery keeps decreasing every year. NASA has to plan carefully when to turn off each instrument so they don't run out of energy too soon. Over the decades, Voyager hasn't been without problems. For example, in 2023, Voyager 2's antenna drifted off by just 2 degrees. That might sound like a tiny mistake, but at billions of miles away, a 2-degree shift means Voyager 2 couldn't communicate with Earth. Luckily, NASA had programmed the spacecraft to fix its own orientation a few times a year, and, just as expected, Voyager 2 corrected itself and contact was restored. Voyager 1 also ran into difficulties. It had a software glitch that made it send data through a broken computer. NASA's engineers spent months figuring out the problem and finally sent a command to make Voyager 1 use a working computer instead. The Voyagers use small thrusters to keep pointing their antennas toward Earth. These thrusters fire in short bursts to adjust the spacecraft's angle. But after flying for decades, residue from the fuel can build up and block these thrusters, like dirt clogging a pipe. To fix this, NASA updated the spacecraft's software to make the thrusters fire less often, but for longer periods when they do. This change reduces wear and tear, hopefully extending the thruster's lifetime by about 5 more years. Even with these challenges, the Voyagers keep flying farther away and still send information to Earth. But the signals are getting weaker and harder to detect. NASA believes that communication with Voyager 1 will probably stop by about 2036. That means we have at most a little over 10 years left to listen to messages from the farthest object humans have ever made.